Now let's see two-dimensional arrays. They are useful for the matrices in mathematics. So let's define the integer numbers. Integer, let it be ARR, array. When it is two-dimensional, you have to define two dimensions. So one is this single dimension and second dimension maybe 4, or both maybe 4, 4, any. Now let's define this is equal to, you have to write in curly bracket the numbers. I just give any numbers, 6, 9, 12, 56, 0, 8, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 12. So 16 we want. So these are the numbers. Now we have to count them for row counting as well as column counting. So let I be for row and j be for column. These are also the variables. So ARR is the name of array. It has two dimensions. This is row, this is column. So 4 rows, 4 columns. So we need 16 numbers. So we have here given 16 numbers. Now let's print this array. So for printing, we have to print row wise. So for I equal to 0 to I less than 4, I plus plus. This will be the first loop for rows. Then the row for columns. For j equal to 0, j less than 4, j plus plus. Now we have to print. So let's printf. The number is in decimal. So %d. And what's that number is ARR. Row is I and column is j. So when I is equal to 0, j is equal to 0, ARR 0, 0 will be printed. When I is equal to 0, j equal to 1, ARR 0, 1 will be printed. In this way, this will be printed. Once this complete row is printed, we have to go on the second row. So for this, let's printf, yes, \n. So it will go on the next line to print the next row. Otherwise, everything will be printed on the same row. So here, the for loop for j completes. So this is matching here. This is matching here. So this is extra. So let's run this program. Run. The numbers, there is no any gap in the numbers. So let's give here tab or maybe any space. 6, 9, 12, 56, 34, 2, 0, 8, whatever numbers we have given, 6, 9, 12, 56, first row, second row, third row, all are printed. So in this way, the matrix, given matrix is printed with the given numbers. Now let's take the numbers from the user. So let's define only 3 by 3 matrix and read the number from the users. So no, numbers are not available. So let's delete these numbers. So only array is defined of 3 by 3. So total 9 elements. I and j for row and column. As it is only for 3 by 3, let's change this for 3. This was for printing, but before printing, we have to read the number from the users. So we have to scan them. So let's write for scanning also. scanf %d backslash t is not necessary. It's not necessary. This is not necessary. But what is required is yes, ampersand. And next line is also not required. So in this way, we read this. So first, from I equal to 0 to 3, j equal to 0 to 3. So 0, 0, 0, 1, 0, 2, like that, the numbers will be taken and they will be printed. If you want, we can print that which number is at which location also. If we want, we can print this way, that ARR, this is, we'll print here that ARR, then we have to print I and J, so ARR %d, this is complete. Then again %d for J is equal to %d actual value. And here we will print I, comma J and comma ARR. So how it will be printed here? Let's give this statement here. Printf ARR 0, 0 and the value will be the first value whatever is given by the user. ARR 0, 1 will be the next value. In this way, all the values will be printed. And after one row, it will be printed on the next row. So let's run this program. So first all the values will be scanned and then all the values will be printed. Run the program. Let's enter the values. 1, 2, 3. I am giving simple values. So all the values are given and it is printed. ARR 00 is 1. ARR 01 is 2. ARR 02 is 3. In this way, we understand that this one has gone to the location of ARR 00. This 2 has gone to the location of ARR 01. In this way, everything is going at the proper location. Okay. Now, let's don't write this information. As we have understood, we need not every time give this information. So let's delete this also. So just run the program. Give any value, suppose 9, 8, 7, 6, 5, 4, 3, 2, 1. So 987, 654, 321, in this way it is printed. If you want the transpose of a matrix, transpose means column and rows, they are interchanged. Then for printing them, just interchange J and I. J and I. So what will happen? 987, it is horizontal here, it will be 987 here. And 963, it is vertical here, it will be 963 here. Let's run this. Give the same numbers, 9, 8, 7, 6, 5, 4, 3, 2, 1. It is printed. 963, 987. So we get transpose in this form. Now let's go to our usual changes. Now this is the first matrix. Let's add two matrices. Then we need a total 3 matrices. Matrix A is first matrix. Then matrix B is one matrix. And matrix C is one more matrix. So 3 matrices are there. Matrix A, matrix B, matrix C. Let's read A and B from the user and generate C, which is addition of A and B. So for reading, this is the procedure. Instead of ARR, let's say now A. For printing, this is the procedure. I just make it short. Okay, it finished. So this is for printing and this is for scanning. So these instructions scan and print one matrix. So let's repeat these instructions one more times for matrix B, and let's write here so we get here matrix A, we get here matrix B. Now we have to generate matrix C, that we have to only print. We don't have to scan that. So only the printing part will be used here. Control C. It's for matrix C. So for I equal to 0 to 3, I plus plus. For j equal to 0 to 3, what we have to do is we have to generate the matrix C and then we have to print the matrix C. So let's generate first here. Every Cij is equal to Aij plus Bij. So Ci Z is equal to Aij plus Bij. A plus B. Now what happens? For I equal to 0 to 3, j equal to 0 3, scan A matrix. For I equal to 0 to 3, j equal to 0 3, print A matrix. Between A and B, let us write some instruction for spacing. Printf not percent, just backslash n, so that there will be one line in between for separation. Now this is reading B matrix and printing B matrix. After printing B matrix, again give this instruction so that before C matrix, again there will be some space in between. Now C matrix, B matrix is printed here, C matrix is generated here. So for j equal to 0 to j equal to 3, there is a curly bracket where C is generated. Now when C is printed, so here the J matrix loop will be ended. This will be ended here, and this is the final end, which is matching with the first. This. Now let's run this program. Enter the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. First matrix. Now I just enter second matrix. I give any random numbers 2, 4, 6, 8, 3, 5, 7, 9, maybe 0. Second matrix, and third matrix is also printed here. This is third matrix. Let's check 1 plus 2. It should be addition. It is printed as same. So something is wrong here. What is wrong? Cij equal to Aij plus Bij. Yes, there is a mistake. Here in the copy paste form, we have kept it B. We should make it C. So rerun the program. 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, you can give any numbers. Second matrix, maybe 8, 6, 4, 2, 3, 5, 7, 9, 1. Second matrix, and the third matrix is generated. Let's check it now. Yes, 1 plus 8 is 9. 2 plus 6 is 8. 3 plus 4 is 7. Correct. This is addition of matrices. Similarly, you can do subtraction of matrix also. Multiplication is a bit complicated, but you can of course try it.